Let's start by creating our VPC. Click the orange Create VPC button. We will create the VPC only here and add the route table and subnets afterwards. Type a name for the VPC. I'll use VPC colon 10.0.0.0/21. Type in the CIDR range, and then click the Create VPC button. We'll add our subnets next. Click the subnets section, and then click the Create Subnet button. Select our VPC ID from the drop-down. Type a name for the subnet. I'll use subnet colon 10.0.0.0/24. I'll select availability zone A. I'll type in the CIDR block, and then I'll click Create Subnet button. I will create a second subnet. This one will be 10.0.1.0/24. I will put this in availability zone B. We have two subnets created. Click the route tables section, and I'm going to rename this default route table. Whenever you create a VPC, AWS will automatically create a default route table for that VPC, and all subnets will use that if they're not specifically associated with a route table. So I'll rename this RT colon default so I know what it is at a glance, and then I'll click Create Route Table button. Type a name for the route table. I will use RT colon 10.0.0.0/21 with private in parentheses. Select the VPC ID, and then click Create Route Table button. It's good practice to associate your subnets with a route table. So select the Subnet Associations section, and then click Edit Subnet Associations button. Select both subnets, and then click the Save Associations button. This forces both subnets to use this specific route table. Let's create the Transit Gateway. Scroll down on the left and select the Transit Gateways section, and then click the Create Transit Gateway button. Transit gateways are regional, and for the name, I'll use TG colon Virginia-01 since I'm in the Northern Virginia region. The AWS VPC in the remote network will connect using the dynamic routing protocol BGP. I will select ASN number 65,000 for the AWS side. Ensure route table propagation is selected. That will automatically add the remote routes into the Transit Gateway's route table once the connection is established. Select the Create Transit Gateway button. The gateway will take several minutes to get created. While that's pending, we can navigate to Customer Gateway section on the left and then click Create Customer Gateway button. The Customer Gateway represents the remote site's router or firewall. It's peering device with AWS. And in this scenario, it'll be a Cisco Firewall. I will use CG colon site-A to represent the remote site with BGP ASN 65,001. If I had additional sites, I would just increment by one. I would call the next site CG colon site-B with 65,002 as the ASN, and then site-C with 65,003, so on. The IP address field represents the public IP of the Cisco Firewall. So I will copy and paste that into the field and then click the Create Customer Gateway button. Next, we'll create the VPN in AWS. Select site-to-site VPN connections on the left, and then click the Create VPN Connection button. Since we're using BGP for the connection, I'll type dynamic-VPN-site-A for the name, and then select Transit Gateway as the gateway type. Select the gateway ID from the drop-down. Select the customer ID from the drop-down. And then I will select Improve Performance of VPN Tunnels, as that will improve performance by using AWS's backbone and its edge locations whenever possible. Select the Create VPN Connection button. Since we selected Transit Gateway as a gateway type, this will automatically create the VPN as a transit gateway attachment. Transit gateway attachments are connections between different resources, like the VPC that we created and the remote network that we're going to have a connection with. I will copy the VPN name and then select Transit Gateway attachment section and paste the VPN's name in the Transit Gateway attachment's name, making it the same. You can make the name whatever you like. I just like to keep it consistent. The VPN attachment is one half of our connectivity, and we will add the second half by adding the VPC as an attachment to the Transit Gateway. Click the Create Transit Gateway Attachment button. I'll use VPC colon 10.0.0.0/21 as the name. Select the Transit Gateway ID from the dropdown. Ensure VPC is the attachment type. Select the VPC ID. Our two subnets are automatically displayed and checked. Click the Create Transit Gateway Attachment button. While the VPN and VPC Transit Gateway attachments are being created, let's edit our route table. Select the Route Table section, select the private route table, select Routes, and then click the Edit Routes button. Add Routes button, and we'll populate this with our remote side LAN. And if we navigate to the Cisco Firewall, issue the command show run interface gig 1/3, we see the LAN is 172.16.31.0/24. Add the LAN as the destination. For target, select the target gateway ID, and then click the Save Changes button. Let's navigate back to site-to-site VPN connections. And we see that the VPN is still pending. It can take up to an hour before it gets created. So let's download the configuration by clicking the Download Configuration button. I'm using a Cisco Firewall, so I'll select Cisco Systems. ASA 5500 is good. VTI is good, and I'll select IKE version 2. Select the Download button, and I will open it in Notepad and move it to the left so it's side by side with another document that I had pre-created. The pre-created document has AWS recommendation commands and phase 1 and 2 of the VPN tunnel. The phase commands and the AWS recommendation commands have already been added to the Cisco Firewall. From the downloaded AWS VPN config file, we're going to copy the group policies, tunnel groups, VTIs, and BGP configuration into our separate pre-made file. Note that when I copy paste the configuration, underneath each section, I will type exit and then exclamation point. You do not have to do that. I learned that when I was younger, and now it's just a habit. It just breaks up the config and makes it clear for me. By default, AWS will give you 2 peers that you will connect with. So I'll copy paste the group policy for both peers in one section, their tunnel groups into another, their interface, virtual tunnel interfaces, the VTIs, into another section, and then finally the router BGP config. Note that for the second peer, I just need its 4 neighbor commands, and I'll add that to the existing BGP config. After copying and pasting the config, we just need to modify it. Under router BGP, note that there's a network 192.168.100.0 mask 255.255.255.0. We need to edit that network and install our own. I will replace it with 172.16.31.0. The mask will stay the same. We also need to edit the tunnel protection IPsec profile and the name if VTI interface and tunnel source interfaces. I will scroll up and copy the IPsec profile that was pre-created and replace profile 1 with it for both VTI interfaces. The tunnel source interface commands have placeholder outside underscore interface. I will change those to just outside because on the Cisco Firewall, its public interface has a name if of outside. On the Cisco Firewall, I need to use unique name if interface names. So I'm going to modify the VTI-interface to VTI 100 and VTI-200. And now it comes to the moment of truth where we copy paste the config into the firewall. No errors. The VPN is still being created. So let's create our test instance. Type EC2 into the services field and then open that in a new tab. Select the Launch Instance button. Type a name for the instance. I will use test-EC2. The AMI and instance type are fine. You can proceed without a key pair, but I had one already created and it's a habit to just select a key pair. We will not be logging in to the EC2 instance, so you do not need a key pair. In the network settings section, you can select your VPC, which we only have one, so it's already automatically selected. One of our two subnets is selected, and we will use an existing security group. We'll change this later. The drive size is fine. Click the Launch Instance button. The EC2 instance will launch and go through two status checks. Note the instance's private IP version 4 address at 10.0.1.5. We will try connecting to that later from our test computer that represents our remote side. Back to the site-to-site VPN connections section, we see the VPN is still pending. And if we click on tunnel details, we see that both peers are in the down state still, which is expected since the VPN has been built yet. So I'm going to pause the video and then bring it back once the VPN is established and both peers are up. And we're back. Tunnel's up, and so are both peers. Let's navigate the Transit Gateway route tables section and review some settings. We see both VPN and VPC have attached and are in a state of associated. In the propagations section, we see both are enabled. The route section shows the remote LAN, the 172.16.31.0/24. And since that's displayed, then we know the BGP neighborship is up and it's attached via the two peers. So now the network connectivity seems okay. Let's try to connect to that EC2 instance from our remote test laptop. I have a laptop directly connected to the Cisco Firewall. And the laptop is in the 172.16.31.0/24 subnet, and its gateway is the firewall at 172.16.31.1. Open a command prompt and try to ping the EC2 instance. And we see request timed out. This is because of the EC2 instance's security group. It's using the default security group, and that does not allow the remote LAN inbound connectivity. So we will create a new security group allowing access. I will open security groups in a new tab. I'm going to name the default security group SG:default. Click the Create Security Group button. Give it a name. Copy paste into the description field. And then for inbound rules, we're going to create two rules. Create a custom ICMP IP version 4 with echo request, since this is inbound, and then an SSH rule. And we will use 172.16.31.0/24 as the source with descriptions of site A. Click the Create Security Group button. Back on the EC2 tab, select the EC2 instance, click Actions, Security, and Change Security Group. Select the new security group, click Add Security Group button, remove the default group, and then click Save. Let's quickly navigate back to site VPN connections and check the peers, just because I'm a little paranoid. Okay, great. Still up. Let's try our ping. And we are getting replies. We'll try to SSH, telnet on port 22. That looks good. Okay, let's clean up our environment. Let's start by terminating the EC2 instance. Select the EC2 instance, click instance state, and then terminate instance. Next is the VPN. Select the VPN, click actions, and then delete VPN connection. Type the word delete and click the delete button. Deleting the VPN automatically deletes its associated transit gateway attachment. Select customer gateways, click action, click delete customer gateway. Select transit gateway attachments. Select the VPC attachment, click actions, click delete transit gateway attachment. Select transit gateways, click actions, click delete transit gateway. Note that all the transit gateway attachments must be deleted prior to being able to delete the transit gateway. Select the Your VPCs section, select the VPC, click Actions, and then click Delete VPC. Type the word delete, click the delete button. And that's the video. Thank you for watching.